So welcome all. We are starting this workshop. This workshop is called Sustainable Manufacturing from Resilient Factories to Sustainable Places. It's a workshop in which 5 projects are clustered. I mean, RARE 2, Restore, Platform Zero, MULTIMOLD, and openZDM. The idea of the workshop is to have a small opening, in a little bit the idea behind the workshop and the Industry 5.0. Then the plan is to have 10 minutes presentation from each of the projects. So RARE will be presented by Alexander Dementiev, Domenico Perfido, and Alessandra Sala. Then Restore will be presented by Diana Rodriguez. The MULTIMOLD by Jacopo Casina, openZDM will be presented by Vangelis Lakas, and then Platform Zero will be presented by Rafael P. Then we will have a small session on gamification, a kind of interactive session coordinated by Martina Digalo, and then at the end we will have the takeaways and the closure of the session. So, well, regarding Industry 5.0 sustainable manufacturing, 3 years ago, if we were involved in European projects, most of the calls, most of the activities were related to Industry 4.0. Industry 4.0 was about short times of production, having digitized let's say the shop floors, the factories, having IoT, reducing, let's say, the potential errors, having a more quality product. In 3 years, it changed a lot in the paradigm. The European Commission started to speak about things related to human centricity, putting the human in the middle, putting the human in the loop, speaking about having resilient factories, putting a lot of emphasis on the survivability of the companies, on how the companies can recover from potential issues, on making products of quality, and also on sustainability. So this is how we link the ideas of sustainable manufacturing with the Industry 5.0, which is at the end the idea of mixing the technology with the human centricity or the human empowerment and the sustainability. Sustainability in terms of reducing waste and in terms of having more green technologies. So this is the idea of this workshop. We are going to tackle the ideas of Industry 5.0 from this different perspective. So we start first with RARE 2, which is about people centricity, which is about resilience, which is about factories. So maybe Alexander, you start first. Let me put your presentation. So the first.
Thank you very much for the introduction. Dear ladies and gentlemen, thank you for attending our workshop. My name is Alexander Dementiev. I'm a senior scientist at the Fraunhofer Institute of Machine Tools and Forming Technology, and my special ratings are going to the participants from our other project participating here in this workshop. So I will do a short overview about our project, human-centered rapid configuration of production, value chain, and fast-changing scenarios. So in our project, we are concentrating on the human-centered approaches to support the different industries and manufacturing processes. So we also are developed some some tools like early detection tool to detect some changes in the manufacturing environment or in supply chains. We also developed tool. Go back to the presentation.
We hide that one.
So I will try it again. Exactly. Thank you. So system level digital twins to support the manufacturing optimization during the production time. Human-centered upskilling tools to support the personnel, to support the workers, and also human-centered and data-driven decision-making to provide the best decision ways for decision personnel. We also have a lot of demonstration cases of use cases like car body parts production at Fontana here near Milano, or contact lens production by company Demco, Carvala, child seat production, and also MMM production of solutions for the sterilization in medical area. And also, last but not least, some ideas or some solutions. Here it is a co-creation tool that also will be presented today by our colleagues. So, interesting thing. So we are developing a ecosystem platform, but we shift a little bit in the direction of the holistic methodology framework, because in the industry we can see a big amount of different IT landscapes. So to provide a unified solution, it was not really possible during the project. So we was forced to shift our focus a little bit to the holistic methodology. So, and also the decentralized architectures from our point of view offer greater flexibility to introduce our development tools into factories. So also the early stakeholder engagement is crucial for the development of such tools. So, and also the problem with semantic models or data quality, and also data structures, all these facts or all these points should be considered at the beginning of the project, the best way to have the end success. So, okay, now I will do a short shift to the topic resilient factories. Sure, at the end, if we can provide a resilient reconfigurable production, also the production places or cities can profit from this idea. So I would say it was the short introduction. Here you can see our partners. We have 22 partners around the European Union. So now I will give the floor to my colleague.
Thank you, Alexander. Hello, everyone. Good morning. I'm Domenico Perfido from R2M Solution. We are both involved in the project in technical and exploitation tasks. Well, I would like to point the focus on the human-focused aspect of the project and how the JavaScript project will try to tackle this target in developing its activities. We are often used to think that technology, rather than help people to do their work, can sometimes and often substitute people. We should have a change in the paradigm. The real innovation basically lies in empowering human capabilities, not eliminating the human aspect. And we should take in consideration this focus point in the activities that we develop. And RunSquare Data Square project basically tackle this aspect, ensuring that empowering human capability could be the real engine of innovation. Well, let's go. We are facing some days and time in which, for example, geopolitical changes, pandemic impact could have a great impact, sometimes negative. We experienced this in the COVID pandemic on the industry. We basically, in a world of global disruption and constant change, we need some resilient factory to be developed. Factory should be able and flexible in order to reconfigure their process and their schematics in order to basically afford this change, external change. But we don't have basically, we have to remind that the flexibility is not only for the innovation technology that we propose in the project, but it's mainly rely with the people that are involved in the work. And for this aspect, Data Square project basically focuses activities on human-centered approach. Basically, we have 5 pilots in our project, and Alexander just introduced these pilots. When we have a lot of input, because pilots are very, very different each one. We have factories that should adapt quickly to external shocks, should be flexible, for production lines. Maybe also with AI-driven tools that already in the project we have developed. But the principal focus of the project is the upskilling of the workers and help them to use this innovation and technology that we have developed. This will, of course, rely in improve efficiency of the factories, reduce downtime, and higher also worker satisfaction. For example, in the Data Square project, we tackle this point on human-centered approach by developing some specific tools. For example, the skill gap detection tool, that is a tool that basically helps manager to identify which knowledge gap there is in their workers, basically, and also find a solution to give them the possibility to understand if they have to upskill existing workers or try to recruit a new talent, for example. So the tool basically point out what is the knowledge gap that is missing at the moment in real time, and also give information how to tackle this aspect in order to have a fast decision making process, basically, that is at the basis of flexibility in a factory line of production and so on. So this tool basically is aimed to transform the human-centered approach and technological disruption into an opportunity for sustainable growth of the industry. The tool so supports each R to convert business goals into needs profile, help the manager to take decisions in a short time and be flexible for the external change, and also assess hard and soft skill of the workers, finding also the way to improve their knowledge and their skills. We also take in account the possibility and the co-creation approach in the production line and value chain by developing our demonstration site number 5, that basically is a sort of online platform that is named Cartoon, which help basically managers, workers, and stakeholders to co-design solution in one user-friendly way. I think that empowering people and giving to workers this possibility really should point to the Industry 5.0, a step forward. And now I give the floor to my colleague Alessandra Synthesis that have developed this co-creation tool. And please, the floor is yours. Thanks.
Thank you.
Sorry, let me just switch the camera. Did you already have your slides loaded?
No.
The other one. Okay.
Okay, so thank you, Domenico. As Domenico said, Cartoon is a co-creation and a matchmaking platform used in Demo 5. So it helps companies and
Sorry.
yeah. Okay.
Okay. Camera is good. Slides. Which slides are they?
This one.
All right. Perfect. Sorry for the interruption.
No, don't worry. Okay, so Cartoon is a co-creation and matchmaking platform, and it is used in Demo 5. It is designed to help companies and solution providers to work together. For example, when a value chain has some unexpected change, Cartoon helps to find fast the right solution. So it starts from one concept, the co-creation, so the collaborative creation. In fact, it supports the connection process, and first helps gathering ideas, issues, opportunities from different stakeholders. The second one is it brings together actors and stakeholders to co-create a potential solution to add value to the value chain. CAR2 is a software platform designed to manage projects and activities, and it used different virtual rooms with different levels and different roles. For example, we have 3 kinds of roles. One is the admin role, the room manager, and the participant. The objectives of CAR2 are, for example, facilitate collaboration, supports on the open calls, and enable a rapid configuration in the value chain, in all the supply chain. Here we have some example of the functionalities of CAR2. First of all, the creation of submission using also during the open call, the select and match to identify solution using the keywords, and draw conclusion, so find the real solution with all the stakeholders involved in the process. So CAR2, what is it? Is the platform that lets users share ideas in a common place, in a virtual place, and so working together to match and create a new solution. So it is like a community for a new collaborative and co-creation process in the whole value chains. Thank you.
Okay. Thank you, Alexandra. I don't know if anybody has any questions. If so, please feel free to ask. If not, meanwhile, I will prepare the next presentation. Okay, no questions? Okay. So, in order to save a little bit of time, we go to the next one, which is the store.
Yeah, I have a video on my presentation, so just to make sure.
Let's see how it goes. I mean, in theory,
Should
the
I
full
just press
screen.
play?
Try if you want.
Try, okay. We will figure it out.
Yeah, in theory, the full presentation, I mean, the full screen is shared.
Yeah,
So let's see.
okay.
So Diana, please.
So hi, my name is Diana Rodrigues. I'm a senior project manager at EWF. So EWF is the European Welding Federation for joining and cutting as well. So we are the coordinators of the Restore project, and I'm here to talk a little bit about the project itself, about the concept of remanufacturing in industry, about a little bit about our use cases, but I also want your input about remanufacturing business models. So I am the project coordinator. So my background is varied. So I am chemical engineering, but I also have a degree in information systems and management. So I'm quite a generalist. So I won't go into the details of the technical solutions, but I will give you a broad overview on what we are trying to develop in the project, and also the challenges we are encountering. And most of all, if you want to engage in a conversation, I'll be more than happy to engage back with you. So remanufacturing is a concept that you probably know already exists for a long time. So the idea is to have like initially complex machinery that would take a lot of time to build and repair and so on. The idea was to remanufacture, take the old parts, repair them, but it was not only repair. The idea was to document, to collect it, inspect it, disassemble the parts as well, repair, remediate, replace, reassemble, test it, and have the seal of guarantee. So in remanufacturing, there are a lot of concepts involved, and depending on the industry, it doesn't really have like a very defined framework, and this is also something that we are studying in this project or researching. So yeah, so like I said, you have, so this is an ecosystem kind of activity, and involves a lot of stakeholders, right? From disassembling to cleaning. Many times there are third parties involved in this operation. So initially, this was done in heavy machinery, but now during the pressures on on our value chains and supply chains. We are returning back to this on how to apply it to all of the components and the equipment that we have in our industries. So yeah. So what is the role of Restore in all of this and how it contributes? So basically, this is just like the technical details. So this is an innovation action. And the idea is to have these 3 pillars in Restore that we want to focus. So it's the sustainable processes, materials, and digital tools. Because not only do we want to remanufacture the parts, the components, we also want to remanufacture it using recycled materials and also processes that are energy efficient, right? So it's not only taking that linear approach, we want to have circular economy principles throughout the whole remanufacturing process. And so these are the main 3 pillars. It's a 4-year project. It started last year, so we are quite new. We are 19 partners. So EWF is the coordinator, and then as industrial partners, we have Dalforsan in Sweden, Lucchini Rail, which is the rail sector, Navtech, shipyard, also Stellantis here. So you know Stellantis quite well, and our partners are the CRF, the Fiat Research Center. Then we have partners that already work with these industrial partners, providing like materials, for instance, welding alloys. So welding alloys is a very big multinational group that produces wire for welding and also powders. So very focused on the consumables for additive manufacturing and welding. We have partners that are more focused on the digital tools like Fraunhofer Sky. So they basically develop a very important part of the project, which is the ontology of the remanufacturing steps. So how to translate the defects that we encounter, the different processes, the different ways into machine speak, so to say, and to embed it into digital tools and also simulation. So and Technovative Solutions is the partner responsible by developing the Restore platform, and actually they are like quite a pivotal partner in everything, because they will take all the findings, all the learnings, and they are building a platform that has also other solutions like life cycle assessment and circularity calculation. So yeah. So basically a little bit more precise. So we have 5 specific objectives. So we want to develop sustainable cladding processes and consumables. So right now, every use case has different components. And we are using a mix of DED, so it's directed energy deposition, PTA, plasma transfer arc, and also hybrid laser PTA processes with recycled consumables where it's feasible, to repair, to remanufacture the components of the industrial partners. So this is the first strategic objective. The second one is to develop the digital tools for increased automation. The idea is also you get the part. I will get more in detail once I explain the use cases. And then you scan it. So for instance, MSC scanning has like solutions that are portable scanners that can go to site and, for instance, scan a propeller or scan a steel roller. Have that on a CAD file, then have this into a simulation tool and perform a lot of simulations before doing the process itself, because this is something that sometimes, many times actually, you have the parts that you want to remanufacture and they're like single parts, things that are decommissioned and that you cannot really test. Everything is different because the defects are different. So the scanning and the simulation on top of the scanned parts is quite relevant in this remanufacture process, because then you can optimize how you are going to use the materials and how you are going to use your processes and what are the best materials. So this is the digital tools, but then also, of course, yeah, okay, I will be very fast. So the idea now is to, on top of it, to develop the Restore platform that will have a lot of tools, and then the business model innovation, because there are a lot of new businesses involved in all this cycle, and then the demonstration parts. So, like I said before, we have the remanufacturing of the rail axle. So this is led by Lucchini. The remanufacturing of steel rollers. Steel rollers are a part on the sheet steel making process. Ship propellers, Navtech, and also the automotive components. Yeah, basically we are around here, so we have already defined the state-of-art analysis, and we are now in the middle, towards the end of the digital models for process optimization, and now we are entering into the part of the exploitation and the business models. Yeah, I will go because I don't have much time. So. In the end, the Restore platform will also have a service for digital product passport. And the idea is to have the parts, to have this incorporated in our platform, in the Restore platform. And with this, there is a lot of ecosystem businesses that can be developed. So right now, we are doing this social awareness campaign, and we are trying to gauge the interest in remanufacturing and what is the status. And some business models that we have been exploring as the product as a service model and component as a service model. So basically, there is a third party connected to this ecosystem of industries that collects the part, scans the part. For instance, this is something also manufacturing as a service for having machines that are like remanufacturing machines, and then we can act as an intermediary. So this is also an approach that we are taking. A lot of questions that we have been asking ourselves is how do we produce these both economically viable products and circularity businesses? And also, how do you create value in all of this? So, and this is what we need from you. So if you have the time, please answer a few questions so that we can really improve our study on business models for remanufacturing. And thank you. I hope I didn't take much time.
Already take the picture. Okay. So we go now with MULTIMOLD. Jacopo is going to present. Jacopo from Casino from Sixes. Let me open it. Remember to be focused on the presentations and take some notes, because later we are going to ask you a few questions in the quiz. We also brought some promotional materials for the winner of the quiz. So, I mean, please.
Thank you for being here. So, as he told me to make some quiz, I started the very first slide with a very simple quiz. Answer in your mind, we are a Lithuanian company. Where is Lithuania? 1, 2, 3. It's there. So, we are a Lithuanian SME that does research with a lot of companies that are members of our network. We have also people in Italy and Greece. So when we talk with us, you will hear several languages. There is a brochure in many of the places, so if you want to bring it home, to remember us. As I said, we are a non-profit organization that works with SMEs to support their innovation. So they interact with us to define their research innovation needs, and we find projects to write together, to prepare together, to bring the innovation that they foresee into European projects and then to the market. We start from an experience on the topic since 15 years of creating companies from European project results. We already have created 2, and 6 years wants to make it as a more structural and structured approach. We have expertise in several domains, mainly circular and digital transformation. We are good in also designing data-driven platforms, and so the IT domain. We work quite a lot in cross-sectorial ecosystems, mainly also with data spaces. I am a data space ambassador from IDSA, and we are on the IDSA topic since mainly its start. So it's almost 7 years we are on that topic. And as I said, what we do is to bring these concepts, these innovations to a market. Just to mention the last one, with one of our companies, we are bringing data spaces to the market with Machinery X, which is going to be a fully industrial and is a completely industrially funded data space. So just to mention as an example. Here we are talking about MULTIMOLD. MULTIMOLD, I think, has a quite clear name because it's multi and mold, so it's pretty easy. So what is our aim is to produce plastic parts that are complex with many kind of plastics, so multi-mold, and electronics embedded directly within the plastic. So you mold the electronics directly within the object, so to make it more resistant, to make it possible to measure things that are else not easily measurable, and to have electronics sealed and secure, because if it's molded into a plastic, obviously is much more resistant than something just attached. Obviously, if you mold something into an object, recyclability is quite difficult. So within the project also we work on recyclability by design, because obviously if you put electronics within an object, how to bring it out, how to recycle everything is a challenge. We are a quite big consortium with Joanneum Research as coordinator, partners like R2M that I think everybody knows here, I guess, and many others. And I will try to focus a little on the use cases, because I think they bring you a little more the idea of what we want to achieve and what we want to do. So the first one is HTP, and they are a company specialized in injection molding for automotive and electronics. Their core aim within the project, which is a very applied one, is to demonstrate the possibility to mold in-mold electronics, so IME, and to have in-mold labeling, so directly within the object to have electronics and the labeling. So they aim to make this scalable, because in small tests is already done, and they want to add tactile functionalities and enable to have surface durability, because if you have the electronics on the surface of an object, obviously you lose part of the resiliency of the surface itself. So it has some complexity. Then, again, as I mentioned, the recycle by design element, which is pretty complex, and they want to start using data and tools, which is obviously one of our key topics, for quality and efficiency. I think here there can be some relations with also the zero-defect domain and so on. The second use case is Schneider Electric, a name that I think most of you knows, is about smart solutions for factories, building, and infrastructures. They want to test a multi-mold operator interface panel. So the goal is to validate industrial design of IME-based interfaces with harsh conditions. So again, plastic molding, electronics within plastic to sustain harsh conditions, like often happens in factories. Imagine also in manufacturing of food, chemicals, and so on. It's quite difficult to keep electronics alive if you don't, okay, you can put them in a big box and then it will survive, but it's not always the best possibility. Also here, scalability and recyclability is a very important element. Last use case. Last use case is about wind turbines. The aim here is to embed within the turbine, within the blade of a turbine, directly the capability of non-invasive monitoring and getting the information from the object. Getting the sensor within the object gives you an edge because you know what is happening inside the object for true. Obviously, it has its own complexity. We are responsible for data management and the digital communication infrastructure. We work on interoperability, traceability, and reusability. Here we used a platform that we developed in previous projects and we are improving here that is called Reuse. That is a platform for circular data management. Reuse enables traceability for circular production. We try to avoid tools like Excel that everybody loves, but obviously makes things quite difficult if you want to share data. In fact, it drives collaboration across industries because when you are talking about recycling, a lot of information has to flow between the one who produced, the one who is going to recycle, the one who is going to use the recycled material. So actually, this is our aim, to facilitate reuse, recycling, repurposes, and remanufacturing of the goods. And obviously, to sustain also the regulatory compliance. The expected key impact is to improve the production efficiency of this complex process, to enhance product functionalities, so to make them better, to support the circular economy, and to support the fact that the complex object will be recyclable by design, and so to create also methodologies to do that, to provide a digital infrastructure that is robust and thought for this aim, and to reduce costs and make it development faster, which is something that I think everybody wants. And obviously, as we are funded by the European Union, we want to make Europeans stronger. That is not so simple, but we try in our little part. And as I think time is done, these are our contacts. You have our brochure if you want, and we are outside here if you want to talk with us. Thank you.
So we go to the next presentation, which is open zero-defect manufacturing from batteries. If you have any question, you can ask now. If not, maybe you can talk with Jacopo, with Alessandra in the stand of 6 or rather 2. Okay, so this is the presentation. Thank you.
Hello everyone, I am Vangelis Lekas and I am happy, it's a pleasure to be here representing openZDM in the Sustainable Places Conference and discussing how the project solutions and digital tools can help with ZDM manufacturing and achieve sustainability and human centricity in the manufacturing sector. This presentation will deliver an overview of the openZDM approach and discuss the current challenges that the manufacturing sector currently faces in achieving sustainability and human centricity. Currently, modern manufacturing companies aim to exploit cutting-edge technologies so that they can achieve shorter lead times, achieve high-quality standards, and increase process automation so that they can make the manufacturing more efficient. And in this context, the ZDM philosophy aims to enable environmental and economic sustainability, but at the same time maintain human centricity and ensure that human remains on the loop rather than being replaced. However, manufacturing industry is facing key challenges in achieving these goals. As traditionally, as quality control largely remains a manual process which may lead to several inconsistencies and bias. And at the same time, defects are identified in late-stage production, which worsens sustainability and leads to limited customer satisfaction and reconfiguration capacity. Human centricity is currently many times being overlooked as human operators are many times being replaced by automation and technologies. To address these challenges, openZDM proposes an AI-based open platform which integrates cutting-edge technologies as three types of NDI systems are deployed into production, and the data coming from these NDI systems are passed in AI modules that predict defective products in real time. On top of that, digital twins are provided for system simulation by leveraging cutting-edge AI-driven models and physics-based models, and are combined with a decision support system tool so that the process parameters can be reconfigured and achieve more efficient production, and so that defective products cannot be propagated. Lastly, LCA modules are being delivered so that the environmental impact can be quantified in production, along with an explainable AI module for making the decision-making human-centered. In the image, we see a high-level depiction of the openZDM approach, where all the technologies are being combined. openZDM achieves sustainability in three main steps. First of all, the NDI is the first step is how NDIs are being combined with AI to measure inline various product characteristics in inline production. And after that, AI is used to make a prediction about the quality of the manufactured products. In the image, we see an example of how a thermal NDI vision system measures characteristics of a steel bar, and then how it is being combined with an deep learning go-to-encounter model, so that prediction can be made about the quality of the steel bar. As a next step, digital twins are leveraged for process configuration. This is being made as digital twins are developed leveraging physics and data-driven models to simulate the manufacturing process. And finally, they are being combined with a decision support tool so that process parameters can be reconfigured efficiently, avoiding propagation of defects. In the images, we see how 3D visualization coming threat visualization provided by the developed digital twins. And an example of the user interface, which is delivered by the decision support tool. Finally, an LCA module is being deployed to quantify the environmental impact of the manufacturing process, which leads to savings in energy consumption and CO2 emissions. On top of that aspect, the human centricity is being ensured by the work of the project by delivering an explainable AI module and also giving the ability to operators to provide feedback in the AI modules so that the system can be improved with the help of the human knowledge. In this way, the human remains on the loop, and the human knowledge is being used by technologies, and the human factor is augmented rather than being replaced by automation. openZDM aims to evaluate its proposed solutions in 5 industrial pilots operating across Europe in various manufacturing fields. Namely, these manufacturing companies are VDLW in Netherlands, Volkswagen, Vidrala, Sone, Arauco, and Aptiv. And in collaboration with these pilots and data coming from real use cases, openZDM developed solutions have so far delivered an impact and some improvements in the manufacturing industries, namely a reduction in battery welding defects by 1.7%. There is a missing dot there. And an improvement in costs due to poor quality of the manufactured products in some pilots by 5%. And also reduction in the costs due to misalignment and quality issues by 80% in the Volkswagen pilot. And as for the human centricity aspect, during experiments and the deployment of the technologies in the pilots, more than 80% of the operators deemed that the explainability aspect was particularly useful. Finally, the openZDM approach and the previous work has shown that the zero-defect manufacturing philosophy can enable and accelerate sustainability by integrating various NDI technologies along with AI-based models, and ensuring that process adaptation can be automated, can work in an automated way so that it can be more efficient. But in all cases, the human remains in the loop, and the process remains human-centric. In this context, openZDM proposes a concrete value as defects are being located in real time and continuously, and the process is being reconfigured so that defectives cannot be propagated, so that defective products cannot be propagated. And in this way, the project leads to defect reduction and waste reduction, so it improves the sustainability of the EU's manufacturing sector. As an acknowledgement to the project, I would like to say that openZDM is currently involves 20 partners, more than 20 partners operating across Europe. And as I said before, 5 industrial pilots are collaborating with the project to assess the solutions. The project is being funded by the European Commission. We aim to address to advance zero-defect manufacturing and with the deployment of cutting-edge technologies and advanced manufacturing, Europe's manufacturing. Finally, I would be glad to answer your questions if you have any. And sorry if I stuttered, but this is my first presentation, so I ask for your clearance. Thank you.
So we go with the last presentation, which is Rafael from the Austin Institute of Technology. He will present the Platform Zero project. Let me open it. Okay. Here, thank you.
Thank you. So, hello everybody. Thank you, Ruben, for the introduction. I'm Rafael Pickel. I'm from the Austrian Institute of Technology in Vienna. I'm a junior scientist, and I'm here today to present to you the Platform Zero project. So, you already see here, Platform Zero is achieving zero-defect manufacturing. So, the main goal is to develop a platform that uses artificial intelligence and cloud-based data structure to improve photovoltaic manufacturing and ultimately end up with zero-defect manufacturing in the photovoltaic industry. To test the findings and the innovation of the project, we have several pilot lines within Europe to see if the claims we actually have will work out in the end. And the claims are to substantially lower the photovoltaic fabrication cost and also improve the quality of the photovoltaic devices. As I already said, we have so we have 4 research centers and 1 university who are specialized in spectral methodologies, imaging, artificial intelligence, and also data management. We have 2 research centers who develop advanced photovoltaic technologies and also have industrial pilot lines already set up in their facilities. We have a methodology SME with strong know-how how to implement industrial processes and monitoring systems. And we also have 2 SMEs in our consortium to help us with the dissemination and exploitation of our findings. So here I already get to the pilot lines. So we have 2 pre-industrial environment and 1 R&D industrial environment. We unfortunately lost one of our partners that we just tried to replace. So for now it's 3 pilot lines. And you can also see that there are different photovoltaic cells, and also they have many different production steps. And within Platform Zero, we try to develop 1 sensor station, 1 advanced sensor station that is flexible to work with all the different manufacturers and also with the different production steps. So I come again to the main objectives of the project. So first, the development of the advanced sensor station, then an AI system for autonomous monitoring and control, then the implementation of a big data management infrastructure and control system, the implementation and installation of functional process monitoring platforms, and at last, the PV manufacturing optimization. So because I have a background in surface inspection, and I am indeed a scientist at the IIT for that reason, I will go into the AI system for the autonomous monitoring, and I hope I will not lose you in the process. So here you can see the advanced sensor station, how it is mocked up. So there's different production or manufacturing processes. So usually the photovoltaic panels get built up layer by layer. So after each process, the module, the sample goes through the advanced sensor station. All the data is funneled to the end, and in the end there's a core processing unit that mirrors all the data into a database, and also the AI system that will then make a prediction after every processing step and classify the sample into standard or deviation. So if it's good, or if you can already stop the production process without moving on. So this gets quite complicated because there's, for every sensor station, there are up to 5 or 6 different sensors included, and we measure the sample at many different sample locations. So I will just shortly an overview. We have, for example, one sample from the first sensor station, so after the first production process, and then we collect data, all the raw data for every sensor, like 1, 2, 3, 4, and so on, for every measuring point. I hope I can make it a bit more clear with this. So we have, for example, a measuring point. The sample goes through the sensor station, and we measure with all the different sensors the quality of the production process that has just been done. To make all of this modular, because we have different manufacturers, and for different processes, different sensors are more relevant. So you can plug in and plug out all of these sensors, and in the end, you end up with a data vector like this, where you just take the photoluminescence, put it in the beginning, photometric stereo afterwards, and you lay them out after each other and train our model with it. So for now, in our state of the project, we have made some tests with all the different sensors for all the different manufacturers, but we haven't set up one of those advanced sensor stations at the plant. So for now, we just try to prove the concept, which we successfully did. So for now, we use linear discriminant analysis to just see how good everything clusters and how good we can classify. We have only a little bit less than 1,000 samples, and we needed to do a 2080 trend test split. You're mostly curious about the results, so we have 90% accuracy in distinguishing between standard and deviation samples, which already shows the robustness of the whole sensor station in the first place, but also the AI prediction. The key takeaways are that different sensors are more applicable in different production stages. The flexible sensor integration is confirmed, so we can plug in whatever sensors we want along the way and also leave some out. And the whole system is modular, and the scalable architecture we planned in the beginning is also validated. So I will now just show you some graphs, because I'm happy to see the clustering here. So we have 3 different samples. Here are the different classes. So we have standard and deviation plus minus for now the 3 manufacturers. And here you can see in the training, everything clusters super well. And in the test, there's a bit of an overlap, but this can also be of a dimensional twist in the visualization. But here also you can see we have a test accuracy of above 90%. And for only having 3 samples per class, so these are the classes and the samples, this is already really nice to see. I'm super happy with those results. And we can now confidentially move in the last stage of the project, where we set up the advanced sensor station and then see how well it works in the pilot lines, and if you need to make some adjustments to the machine learning. Also, another part of the last project step is to have an interface for the operator of the system, so they can get feedback why the AI system made a prediction, and what sensor and what part of the sensor vector made the AI make why the prediction is made, so that the operator of the system can see, okay, for photoluminescence, for example, and these wavelengths, there's a spike, and that's why the prediction is standard or deviation. And this should help then the operator also make a decision. This happens all the time. That's not a problem. We can move on, or they can just accept the prediction and ditch the sample. But this will be we can only see once we set up the pilot lines. So I hope you could follow me through also the technical part of the presentation. Please get in touch with us, and thank you for your attention.
Okay, if there is any question, if not, I mean, maybe we'll go to the data session, and at the end, if we have time, we ask some questions, okay? So we have prepared, thanks to Martina, who is leading the activities related to gamification and participatory approaches at R2M, we have prepared a kind of a quiz to see if you have been focused on the presentation or not. And let's see how it goes. Okay, let me try to open it. So it should be this one, present, is presenting, loading. Can I put it full screen? It should be okay, yeah, we can see this.
Okay.
So it should be. Okay, let's do it this way. Okay.
So yeah, the idea for this session, we have subdivided this session into parts. The first one is more also to collect your ideas and feedback concerning the presentations and in general, let's say, what are your ideas related to the sustainability and circularity aspects of factories and industries. And then we have prepared some questions that will, let's say, be the gamification exercise. You will have a ranking, a leaderboards, and at the end we will, we will give these small prizes. So you can connect using the codes up here. So the first question, just to warm up a little bit, it's what words come to your minds after all these presentations? So we will have here a cloud of words. So we have process, innovative, human in the loop, sustainability, okay, collaboration, implementation. Okay. Technologies. Okay. Sustainability process. Efficiency. Okay. So industry. Okay. Let's give some. Okay, so let's say that AI is the most important one. But yeah, okay. Circular economy. Okay, very nice words. I don't know, also, Ruben, if you have any comment.
No, it's fine. I mean, we already have like 10 person, 14 person connected, so let's go to the next one.
Okay, so this one should be a ranking. So based on what you have seen today, which actions or strategies do you think are the most important to make a factory or an industry more sustainable and resilient? So you have the first option, it's investing in renewable energy and energy efficiency. Then you have reducing waste and using recycled materials. Then training and empowering workers on sustainability practices, and then digitalization and data-driven management. So at the moment, using a lot. Okay. So, okay. There is no, let's say, right or wrong answer. It's just also curious to see which actions and which strategies should have the priority.
It's quite balanced, so it's good.
Yeah.
Okay. We already got 50 replies, so maybe we can switch to
Yeah.
the next one.
Okay, then the last question for this initial session is, how do you think people, technology, and circular resource use can better work together to shape the factories and industries of the future? So, possible answers. So you have to say if you agree or disagree with the statements. So by creating collaborative design and innovation processes, or like by integrating smart systems that track and optimize resources, by promoting cross-sector partnership and sharing data, by promoting cross-sector partnership. Duplicated, sorry, this is a typo. Okay.
It's interesting because two ones that are duplicated don't have the same score. So there is something, okay. But this, I mean, maybe it was a good idea to put something like that, so to see, okay. Thank you. Already everybody voted, so let's start with the game. I mean, now is the game. You need to be fast and right, and yeah, the winner gets the award. So this is
First. Okay.
So we have 16 partners, players. So let's start. Yeah. Be quicker.
So which project has not participated in the session? So Reset, Platform Zero, Rare 2, or MULTIMOLD?
This one is easy, come on. Okay. So there are 3 persons that were.
Let's see the results.
So which one the? Okay, so Mars is winning. Okay, let's see how it goes. The next one. Okay, question 2.
Okay.
We are ready.
So how many different projects have been presented?
So another easy one. I mean. Okay. So somebody skipped at least one of the. So we see that who is winning. Bangladesh. Okay. Good. Okay. Next one.
Okay. Let's go. So openZDM presentation was about
From chaos to zero defects, from AI to zero defects, from data to zero defects, or from waste to zero defects. Okay. Okay, let's see the ranking. Probably Evangelis will present it. Okay.
well, it's getting interesting.
Okay.
Okay. So next
So let's go to the next one.
So Restore mentioned DPP. What are DPPs? So digital permits plan, defect prevention plans, digital product passports, detailed process plan. Okay.
Okay. So still Violis is leading. Okay. Let's see the next one.
Number 5. Rare 2 is Profit-centered, human-centered, system-centered, music-centered. Okay.
So the last two questions. Okay. This one, I mean, reduce a little bit the distance from Vangelis, but Vangelis is still living.
Yeah.
Okay.
Last two questions.
Last two questions.
So, in which industry Platform Zero focused? Is Platform Zero focused? Agri-food, sports, aerospace, photovoltaics. Okay.
Well, the result was
Photovoltaics.
but
Yeah. Sorry.
Okay, so the distance is reducing. Okay, we
Okay.
have Vangelis and Beyoncé. Okay.
So,
Last one. It is about MULTIMOLD. Let's see how.
So multi-volt, revolutionized manufacturing with turbocharged assembly lines and advanced injection molding, factory ninja skills, and more innovation.
Okay. Okay, let's see the winner.
Well, actually, it was Hugh.
It was our in reality it was, but I mean, yeah. So I think that we have a winner. So I suppose that is you. So thank you. Okay, we finished on time. If anybody has any question or whatever, if not, I mean, I can ask Rafael about linear discriminant analysis, about why you have used it, or if you want to say a few words, if anybody have any other questions.
Any other questions? Feel free.
Why you use 80% in test and 20 in training?
Because we only have 1,000 sample points, and we want to make, if we would do it the other way around, as you usually would do, you train on 80% of the data and test on 20%, the accuracy would vary from like 50% up to 90%, depending on the random split you make. So that's how we made sure to have a statistical significance and still an accuracy of 90% is very promising. So you can see the data we have clusters or classifies nicely, and the more data we get, we can also use more sophisticated approaches. Maybe you don't have to. It's always nice if you can stick to basic things like the LDA, the discriminant analysis, which is like 40, 50 years old. But yeah, if it works, it works. So for now, we are happy with the results, and it just shows we can move on with the system we planned at the beginning.
Okay, thank you.
Yeah. Thank you for the question.
Any other question? If not, I close the session. And if
I have a question, also a question to our Austrian partner or colleague. Do you mean the PV production in Europe is still profitable? Because in Germany in the last years, a lot of PV fabs was closed. They are closed.
Honestly, I don't have knowledge of if that's the case, but also we work with research centers, so the photovoltaic panels they produce are quite innovative. So some of them are see-through, others are flexible. So it's not about so they're developing new methods for the photovoltaic market. So I'm not sure if they are actually competing with the already existing market or if they try to open up a new one. But also, I'm not the.
It's a very interesting question for me.
Yeah.
Good, thank you.
Perfect. So we have had 5 interesting projects, or in some way the Industry 5.0. So Industry 5.0 is quite recent. Let's see what happens, because in the last few months we have seen a lot of artificial intelligence science that are autonomous. They are not normally human-centered. So let's see I don't know if we are in a Industry 5.0 phase that is going to be very small, and we are going to see a sort in a Industry 6.0 focused on agents in autonomous systems and less in humans and less in sustainability probably. But let's see how it goes. Probably next year in Sustainable Places 2026 in Luxembourg, we can talk again about Industry 5, 6 or whatever. Thank you for coming. I hope that you had a nice time.